Hello guys, welcome back to my YouTube channel. So today we are doing electrolysis, but before we get into electrolysis, there are some basic concepts that we should make sure we understand before we start doing electrolysis. So let's just do a recap of those basic concepts. Okay, so we have got our periodic table here. We've got our group 1 in the first column, group 2 in the second column, elements in group 3, elements in group 4, group 5, group 6, group 7, group 8. Okay, and these elements, they form their respective charges. Okay, as you can see, group 1, it forms a charge of what? Of plus. Group 2, 2 plus. Group 3, 3 plus. 4, 4 plus. 5, 3 minus. 2 minus, and minus. Okay, so this is how it goes. We've got our magnesium. This is magnesium element. Okay, we have our magnesium element here. So if magnesium element is to form an ion, it forms an ion of what? Magnesium is in group 2, so it forms an ion of what? Of 2 plus. So we get magnesium what? 2 plus. Okay, if we pick another element, let's say aluminium. Okay, aluminium, this is an element. Okay, if it forms an ion, it forms an ion of what? Aluminium is in group 3, so it forms a charge of what? Of 3 plus. So if we get aluminium 3 plus. Okay, so this is an element, this is an element, this is an ion, this is an ion. Okay, so that's how they form their what? Their ions. So if we are to pick, let's say oxygen. Okay, we have got oxygen element. This is an element. Okay, if it's to form an ion, it forms an ion of what? Of 2 minus, because it's what? Oxygen is in group 6, so it forms an ion of what? Of 2 minus. So it's oxygen what? Oxygen 2 minus. Okay, if it's sodium. Okay, let's say sodium. We have sodium in group 1, so we have sodium. If it's forming ion, it forms an ion of what? Of Na plus. Okay, so these are the ion formation of these elements. Okay, we've got an element in this ion, element in its ion. Okay, so it's important to know this when you are doing what? Electrolysis. Okay, so now we're going to look on how compounds are formed. Okay, if we react two elements or more, we get a compound. Okay, so let's say we are to react sodium. Okay, the chemical formula for sodium is what? Is Na. So react sodium plus, let's say, chlorine. Okay, CO2. Okay, chlorine is a diatomic, so there is equals 2. If you write chlorine, we put a what? With a 2. All elements in this 7 formation, okay, starting from nitrogen here to fluorine down to iodine. Okay, these elements in this 7 formation, they are diatomic, so when you write them with a 2. Okay, the x is 2, like this, and we get what do we get here? So here sodium is sodium plus. This is how they react. The ions are the ones which what would react. Sodium is in group 1. Sodium is in group 1, so it forms an ion of what? Of plus, or 1 plus. Okay, chlorine is in what? Is in group 7, so it forms an ion of what? Of Cl minus. Okay, or minus 1, Cl minus, same thing. Okay, so here we only take the numbers, not the plus. Okay, so when they react, this charge for sodium, it drops here. Okay, and this one drops where? There, such that when we write the compound, the formula for the compound will be like this. Na, the number which is coming here, is this one, which is coming from where? Which is coming from the charge of chlorine, which is 1. Okay, it's minus 1 or 1 minus. We only take the number. Okay, so it's 1 here. And the red chlorine, the number which comes here is the one which is coming from where? From the charge of where? Of sodium, which is plus 1. We only take the 1 here. Okay, so this one means we've got 1 sodium, and this one means we have 1 what? Chlorine. So we just write it like what? Like Na what? NaCl. So this is the what? The compound formula for what? Sodium chloride. When we react sodium and chlorine. Okay, sodium what? Chloride, like this. Okay, this one is an unbalanced. This is an unbalanced equation. So we have to balance this equation, okay? Every chemical equation should be what? Should be balanced, which means the number of sodiums at the left-hand side should be equal to the number of sodiums at the what? At the right-hand side. And the number of chlorines at the left-hand side or in the reactant side should be equal to the total number of chlorines at the what? At the right-hand side or at the product side, okay? Here we've got 2 chlorines, okay? Here we've got what? 1 chlorine. So we have to balance. We put a 2 here, okay? This now means we have now 2 chlorines. 2 chlorines are balanced. Here we have 2 sodiums. Here we've got 1 sodium. So we also put a 2. Now this equation is now balanced. So this is how we form what? This is how we form a compound. This is how a compound is formed. Okay. So let's do another example. Okay. So right now, if you are to react magnesium and what? And chlorine. Okay, let's say magnesium and oxygen. Let's change and oxygen. Okay. What do we get? How do we get the formula for the compound? Okay. Magnesium, we check the ions. Okay. Magnesium is in group 2, so it has a charge of what? 2 plus. 2 plus here. And oxygen is in group what? It's in group 6, so it forms a charge of what? Of 2 minus. 2 minus, like this. Okay. So when we write the resultant formula, what do? We drop these charges. This one goes there and this one goes there. Magnesium with a 2 which is coming there, and oxygen with a 2 which is coming from where? From there. So here, these numbers, they have what? There's a common factor, which is 2. So we divide by the common factor, okay? Which is 2. 2 here, 2 here. Then the 2 cancels out. We are left with what? Magnesium oxide. With magnesium oxide. Then the chemical equation should be what? Should be balanced. So this is the resultant compound formula. For what? For magnesium oxide. Okay, for magnesium oxide. Okay, this is the compound. It came from where? It came from magnesium and oxygen. So when we want to balance, we have 2 oxygens here, so we put 2 here. We now have 2 oxygens. We have 2 magnesiums. We put 2 here. So the equation is now what? It is now balanced. Okay. Now let's identify ions present in a compound. Okay, we've got calcium chloride. Calcium chloride is a compound. Okay, it's a compound formed from what? From calcium and chlorine. Hence, calcium chloride. It formed from what? Calcium and what? And chlorine. So calcium, it has got a charge of what? It's in group 2. Like we say, group 2, charge of what? Of 2 plus. Chlorine is in group 7, so it forms a charge of what? Of minus. Okay, it's 1 minus, so it's just minus. We don't write 1 minus when it's 1, so it's minus. So these are the 2 what? Ions present in what? In calcium chloride. So these are their basic concepts that you understand before getting it what? Into electrolysis. So now that we have got the basic concept, so now we have to go to electrolysis. Let's now begin electrolysis. Okay, now for electrolysis is the process of using electricity to break down or decompose a compound. If we have magnesium chloride here, okay, we have shown you how to deduce the compound formula for compounds. We have magnesium compounds. Okay, magnesium chloride is formed from what? Is formed from magnesium and chlorine. Okay, magnesium and chlorine. So if we want to break down this compound, into what? Into magnesium and chlorine separately, that's when we're using what? Electrolysis. So it's used to decompose this compound into what? Into magnesium and chlorine. Okay, depending on what compound you have, we're just splitting that compound. Okay, in simple terms, we're splitting the compound into what? Into magnesium and what? And chlorine in this case. So that's what we... Okay, so this is how electrolysis works. Okay, so we want to break down sodium chloride into what? Into sodium and what? And chlorine. Using what? Electrolysis. Okay, using electrolysis, I'm going to balance here real quick. Okay, every equation should be balanced. Okay, so we want to break down sodium chloride into what? Sodium and what? And chlorine. What do we do here? Okay, we've got our beaker here, or this container. Okay, so we put sodium chloride in the beaker. That's the one we want to decompose. So the compound to be decomposed is called the what? It's called the electrolyte. So in this case, sodium chloride is what? Is the electrolyte. We've got the beaker. So we put sodium chloride inside. Then we have to pass electricity through what? Through the what? Through the sodium chloride so that it can be decomposed. Okay, this one is the what? Is the battery. Okay, it's the battery. So this is the positive terminal and this is the what? The negative terminal. So electricity moves from the what? From the positive down into the what? Down to the carbon. These are the electrodes. Okay, electrodes. They can be of carbon or platinum. Okay, so these are electrodes or carbon electrodes or platinum electrodes, whatever material, not whatever material you want to use, but we'll get in that later. So electricity moves from what? From the positive to the what? To the negative. And the electrons move from what? From the negative to the what? To the positive. So by there, that's when decomposition of sodium chloride happens. Okay, so right here in this sodium chloride, what happens during electrolysis? In this sodium chloride, we've got ions. Okay, we've sodium ions and what? And chlorine ions. Okay, so this is the positive ion, this is the what? A negative ion. This is the what? Cation, and this is the anion. Cation is a positive ion. All positive ions, positively charged ions, they are called what? Cations. And negative charge, they are called what? Anions. So what happens here is that when electricity passes through what? This electrolyte, these ions, okay, this positive is attracted to the what? To the negative terminal, okay, or to the negative electrode. Okay, these are the electrodes. These two are the electrodes. So this one is attracted to the what? To the negative electrode, and this negatively charged ion or the anion is attracted with to the positive. Okay, and like charges, the what? They attract. So this is what happens where? This is what happens on electrolysis. The positive, they attract the negative, and the negative are attracted to the positive. So this is what happens. So now we are going to deduce the equation that happens in the anode and the what? And the cathode. We're going to deduce the anode and the cathodic reactions or the equations that happens during what? Electrolysis. Meaning that we are going to write the anode equation and the cathode equation during electrolysis. So as you can see, chlorine minus Cl minus goes to the what? It's negative, so it goes to the positive terminal or to the positive electrode, and sodium plus it goes to the what? Negative electrode. So we're going to do electrolysis for molten compounds and aqueous compounds, dilute compounds, and concentrated compounds. So we are going to write their equations. We're going to do electrolysis for those compounds and see what will the equations look like. So we're going to start with molten compounds. So we're now doing electrolysis of what? Of molten compounds. So what I'm going to show you here applies for what? For all molten compounds. Okay, we'll be just doing the same thing. So if they change, if it changes in the same molten, the same magnesium chloride or magnesium oxide, the process is what? The process is the same. So you have to appreciate the concept here. So what we are saying is that we want to decompose molten what? Sodium chloride using electrolysis. Okay, so we have got what? Sodium chloride. I showed you how to deduce the compound formula for them. Here we've got okay, this is the positive electrode, this is the what? The negative electrode, as you can see here. Okay, positive and negative electrode. Okay, so in sodium chloride, what happened in sodium chloride? In sodium chloride we have what? sodium chloride, we have two ions. Okay, ions present in sodium chloride. We have got what? We have got sodium plus and what? And chlorine minus. Sodium plus and chlorine minus. These are the what? These are the two ions which are present in what? In sodium chloride. So what happens at the anode? We are now writing the equations. Okay, the equations for them. The anode is the what? The anode is the positive electrode. So what is attracted to the positive electrode is the what? Is the negative ion. Meaning that the Cl minus, which is coming from what? From chlorine, from sodium chloride. The Cl minus is attracted where? To the positive electrode. So what happens at the anode? This is what happens. An anode is positive, it attracts what? The negatively charged what? Chlorine. The negatively charged ion. So here we've got chlorine minus, Cl minus. Okay, we've got Cl minus. What do we have? Cl minus, we get what? Chlorine. Okay, when chlorine is being written as an element, it's diatomic, as I said. Plus what? Electrons. But right now, we don't know how many electrons. Okay, so for negatively charged ions at the anode, okay, negative charged ions, the electron will be produced where? At the right hand side. But for positively charged, you're going to see when you do positive charge ion for sodium, the electrons will be found where? At the left hand side. Okay, so that's what will be happening. So what we do is this: we don't know how many electrons yet. Okay, so the first step here, after we do this, we write what? We write the we have to balance this equation. Here we've got two chlorines, here we've got one chlorine. Okay, so we balance, we put 2 here. Then we put here, when they are balanced now, we now put the number of electrons here. Where do we get the number of electrons? We multiply 2 by what? By this charge. Okay, we look at the ion. Okay, then we multiply the number which will be here by this one. So say 2 times 1, but there's 1 here. 2 times 1, we get what? 2. So it will be what? 2 electrons. So this will be what? The anode equation. Okay, then if we get to the cathodic equation, the cathode is the negative term, it is negative electrode. So the negative attracts the what? The positive. It attracts the positive what? Ion. So sodium Na plus. Okay, I say that for positively charged ions, the electrons are formed where? At the left hand there. Plus how many electrons? We don't know how many electrons yet. Okay, so we leave a gap here so that we can put the number of electrons to give what? To give sodium. Okay, to sodium here. So now we want to balance the sodiums. Okay, the sodium, we have got 1, we have got 1, so it's balanced. So how many electrons here? We go to the ion. Here we've got 1 here. It's not written, but there's 1 here. Okay, so you say 1 times 1 here, we get 1, so it's just 1 electron. So it's good like this. So this will be what? This would be the cathode equation. Then for the overall equation, what are we doing? We're just decomposing this. Okay, so it's just simple to say chlorine, sodium chloride. At the end of the day, we're decomposing sodium chloride to what? To sodium plus what? Plus chlorine. Okay, sodium and chlorine. So yeah, we've said that chlorine is what? Is diatomic, so there exists 2. When you write chlorine, I've given you that 7 formula in the periodic table. This one, all these elements from nitrogen to iodine, they exist as what? As diatomic. So we write 2 whenever we write them when they are standing alone. So we now at the overall equation, at the end of the day, we are decomposing sodium chloride into sodium and what? And chlorine. So we now balance every chemical equation should be what? Should be balanced. We have 2 chlorines here. Here we put 2. Okay, when we are balancing, we put numbers here. Don't put small numbers here or here. When you're now balancing, we put only, the numbers here, which affects that whole compound. Here it means that we have 2 sodiums and 2 chlorines. Okay, so we have 2 chlorines, 2 chlorines. Chlorines are balanced. You have got 1 sodium and 2 sodiums. So we put 2 here to balance the sodiums. So this is for what? For molten compounds. So this is how we balance. Okay, this is how we balance the equation. This is how we deduce the equation. So this process is the same everywhere. Okay, let's do another example for molten. Okay, so another example. Describe the electrolysis of molten magnesium oxide. So the first step here of what? Molten magnesium oxide, this one. So the first step here, what's to do? What do? We write the ions present in magnesium chloride. What do we have? We've got magnesium 2 plus from magnesium, okay, and O2 minus from oxygen. So these are the what? These are the ions present. Okay, so when we now want to write the equations, okay, anode equation. Okay, now we are on anode. For the anode equation, what do we have? The anode is the positive electrode, so it attracts the what? The negative ions. So in this case, our negative ion is what? Is oxygen, O2 minus. So we say O2 minus, okay, to give what? So if I said that if the ion is negative, the electrons are formed where? At the right hand side. To give what? To give its element. Okay, oxygen is diatomic in that same information. Okay, in that same information is what? It's diatomic. Plus what? Electrons. We don't know how many electrons yet. Okay, so here we now want to balance. Okay, we now want to balance the oxygens. We have 2, you have got 1. This 2 is for charge. It's not indicating that we have 2 oxygen. Okay, so it's 2 and you have 1 here, so we put 2 here. So you have 2 oxygen, 2 oxygen. The oxygens are now balanced. Now we want to put the number of electrons. Okay, how do you know the number of electrons? We go to the ions. Okay, to the ion here. We multiply this number with the charge. So we say 2 times what? Times 2. Then we get 4. That will be the number of the electrons. Okay, so that means that at the anode electrode, what do we get? We get oxygen. Oxygen is going to be formed there. If you seek back where I drew the diagram, okay, at the diagram for electrolysis, at the anode electrode, we see what? We see bubbles. Those bubbles will be bubbles of what? Of this oxygen. Then going ahead with the cathodic equation. Then with the cathode equation, the cathode is negative, so it attracts the positive. In this case, our positive what? Is magnesium 2 plus. Okay, so we say magnesium 2 plus. Okay, so if the ion to be discharged is positive, the electrons are written where? At the left hand side. So we say plus. How many electrons? We don't know how many electrons yet. Okay, to give what? It's what? It's responding what? Element. Okay, so first thing we balance the magnesiums. We have got 1 magnesium here and 1 magnesium here. It's now balanced. Okay, so here we've got what? Here we've got 1. Here we've got 1 magnesium, 1 magnesium. Okay, so how many electrons do we have? We go to the ions, we multiply 1 times what? Here we've got 1. 1 times 2, we get what? 2 electrons. So that will be for the cathode. Then for the overall equation, overall, what are we doing? At the end of the day, what are we doing? We're just decomposing what? Magnesium oxide into what? Magnesium and what? And oxygen. So we have magnesium oxide is going to be decomposed to what? To magnesium and what? And oxygen with a 2. Okay, we said that oxygen is diatomic, so the exists as what? As 2. So we have to balance the equation. So here we've got 2 oxygens, so we put 2 here. 2 oxygens are now balanced. 2 magnesiums, we also put 2 here, so the equation is now balanced. So this is what will be happening. Okay, so when you write an ion, okay, at the other side you write the corresponding element for that ion. Okay, then the electron, I've said that if the ion is negative, okay, the electrons are written where? At the right hand side. If the ion is positive, the electrons are written where? at the left hand side. Okay, then after you write let's say here, after you write the ion, or after you write the ion, at the other side, always at that side, you should write the corresponding element. Here we've got magnesium, here we've got what, oxygen, and the electrons I've showed you how to write them. So that's for molten. Let's go for to dilute. Okay, so now we are doing electrolysis of dilute or aqueous compounds. Okay, so if a compound is dilute or in aqueous form, it means that there is also water in there. Okay, so for when we did for molten, there was no water. There were just those ions in that compound. Okay, so for dilute aqueuses or dilute or aqueous compounds, and the ones which you are going to do for concentrated, all of those remaining, all of those ones which are doing from now, there will be now water inside. Okay, so here water is what? Water is H2O. Okay, so if water is H2O now, the ions present in water, it's what? We have H plus and what? And OH minus. Okay, these are the two ions that we find in what? In water. Okay, so these ions find in water. So you have to know that. Okay, so for now, for electrolysis for dilute or aqueous sodium chloride, okay, the first step, find the ions present. Okay, that's the first step for all electrolysis of every compound. First step, you identify the ions present. Okay, what do we have in sodium chloride? Okay, here we've got this one, sodium plus, Cl minus, and what? And the ones from water, H plus and what? And OH minus. Now we have got 4 ions. In molten we had what? We had only 2. If this was molten, the ions present would be what? Would be this one and this one only. Okay, but now that is now dilute, there's now water involved. So we've got what? In addition, we have H plus and OH minus. Okay, so going to the anode equations, we're now going to the equations, sorry. Anode. The anode electrode is the what? Is the positive. So if it's the positive, what does it attract? It attracts the negative. Okay, it attracts the negative. So the negative ions. So which negative ions do we have? We've got Cl minus and OH minus. But only one N ion is going to be what? Only one ion is discharged. Okay, only one ion is what? Is discharged. So here we've got, but which one now? Which ion is the one which is going to be what? It's going to be attracted there. The ion, the least reactive ion is the one which will be attracted, the least reactive. So Cl minus and OH minus, which one is the least reactive? So there's one which we call the reactivity series. Okay, here we've got reactivity series. This reactivity series for what? For cations. Okay, for cations. I'm sorry, it cannot all fit in the on the screen, but you can pause the video and see. You can pause the video and see what we're saying here. Okay, so this is the reactivity series for what? For the cations. Okay, for cations, what do I mean? I mean the positively charged what? Ions. And this one is the what? The reactivity series for the what? For the anions, or for the negatively charged. Okay, so with the most reactive at the top. Okay, the most reactive at the top, with the least reactive at the what? At the bottom. So here I said that the one, the ion, the least reactive will be what? Will be attracted first. So here, for n ion, for this is how you just claim it. Okay, it's posokama auzinfela haikosigo. Okay, posokama auzinfela haikosigo. I'm not sure they will give you all these ones in their order in the exam, so you have to claim it. Okay, it's posokama auzinfela haikosigo. Posokama auzinfela haikosigo. Okay, with their corresponding what elements. For Po, it's potassium. K is the chemical formula for potassium. So sodium, with the chemical formula for sodium is Na. Then Ka, it's calcium, magnesium, aluminium, zinc, Fe it's iron. La, it's lead. Hi, hydrogen. Co, copper. C, it's silver. Then Go, it's what? It's gold. So these are the what? They are the reactivity series for the positively charged ions or for the cations. And this one is for the what? For the anions. Okay. So we've got the chlobrio. Okay. Claim it like that. Chlobrio. 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 Okay. This is the chlorine. This is the bromide or the bromine. This is iodide. This is the hydroxide or the hydroxyl. Okay. So when there are now two ions, I said that only one is attracted. Okay. Then the other one remains. We don't want the one which remains. Doesn't matter. Okay. We only want the one which attracted. So when there exist two ions, how do you know the one which is going to be attracted? We look at the what? At the reactivity series. The least reactive will be discharged. So that means if you're comparing two things, if you're comparing two ions, the one which will be low is the one which what will be discharged or attracted. Okay, so coming back here at the anode. Okay, here at the anode, the remaining things is just the same. Okay, so the only new thing is the reactivity series and what these additional ions. So at the anode here, the anode is a positively electrode. It attracts what? The negative. Here our negative is what? Is CO minus and what? OH minus. So which one is going to be attracted? Okay, we have got CO minus and what? And OH minus. Which one is the least reactive? The least reactive is one which will be below, which is what? The OH minus. So the OH minus will be what? To be discharged first. So for all dilute or aqueous compounds, the anodic equation is the same. Okay, so if you're writing the anode equation for dilute or aqueous compounds, you don't have to think. The equation is what? Is the same. Okay, this is the equation. Plus 4 electrons. Okay, just know the equation like this one. Okay, just claim the equation like this. So for all, if you are to write an anode equation for dilute or aqueous compounds, this is the what? The equation. You don't have to think. You just have to write on anode equation. You write this. You don't have to think. Okay. So for the cathode equation now, this one varies with the compound. Okay, but this anode for dilute and aqueous compounds is the same. You don't have to think. You just write it like this. Okay, so now for the cathode is the negative electrode. So it attracts what? The positive. Which positive? We've got sodium here and what? And hydrogen. Sodium and what? And hydrogen. So looking at the reactivity series, which one is going to be attracted? We have sodium. We're now at the positively charged ions, okay? We have sodium and what? And hydrogen. Which one is the least reactive? The one will be below, which is hydrogen. Hydrogen is below sodium in the what? In the reactivity series. So the hydrogen ion is the one which is going to be what? To be attracted first. So it's hydrogen. Okay. H plus, the other thing is the same. Okay. H plus, if it's plus, the electrons will be formed where? Will be formed at the left hand side. Plus, we don't know how many electrons yet. Okay. So we just write electron, leave space to put how many electrons to give what? The corresponding what? The corresponding element. Okay. Hydrogen is also diatomic. Okay. Hydrogen is also diatomic. So in addition, I said that from nitrogen, in this 7 formation, nitrogen to fluorine down to iodine, these are diatomic. They exist as 2. And also hydrogen. Hydrogen is here, but it's what? It's in group 1. Hydrogen is in group 1. Okay, it's not in the transition elements, not in the middle here. It's in group 1. Hydrogen it's here. So hydrogen also in hydrogen. I'm not saying all group 1 also are diatomic. No, hydrogen is also is another. It's the only diatomic, which is not what in this same formation. So it also exists as 2 So we put 2 here. Okay. So after we write this, what's the next thing? We balance what? The hydrogens. We have 2, we have 1, we put 2 here. Hydrogen, we have 2, here we've got 2. Hydrogens are now balanced. Now, how many electrons do we have? How do we know the number of electrons? We go to the ions, okay, to the ion. We multiply 2 by what? By that charge. So it's 2 times 1, then we get what? 2. So this is the cathode equation for what? For O what? Not for O. Yeah, this is the for cathode equation for this compounds. For this dilute or aqueous what? Aqueous compounds. So at the cathode, what do we have? What do we see at the cathode? Okay, if I'm to draw the diagram will be like this. Okay, this is electrolysis of what? For dilute sodium chloride. Okay, so they'll ask you, what do you see at the cathode? This is hydrogen. Hydrogen is a gas. Okay, so at the cathode, this is the cathode. This one. This is what? The anode. So at the cathode, you're going to observe what? Bubbles of what? Of hydrogen. Hydrogen is going to be formed at the cathode. Okay. So when they ask you, what do you see at the cathode? You don't have to guess. It's not a guesswork. You write the equations and you see that what is being formed at the cathode. Okay. At the cathode, we get what? Hydrogen gas. So you see bubbles of hydrogen gas. Okay. So here at the anode, what do we see? At the anode, the water is formed. Of course, you can't see water if the whole thing is colorless. You also see bubbles there, but there will be bubbles of what? Of oxygen at the anode here. So that's what will be formed at the anode side here. There will be formed water and oxygen, and at the cathode will be formed what? Hydrogen. So you see bubbles of hydrogen and here bubbles of what? Of oxygen. Okay, so let's do another example for dilute magnesium bromide. Okay, so the first step is to identify the ions present. Okay, let me write here. The ions present. Okay, what do we have? We've got magnesium 2 plus and the Br minus, but it's now dilute. Okay, so there's no water involved. So the ions from water is H plus and what? And OH minus. Okay, now for the anode equation, anode is plus, it attracts the what? The negative. So for dilute or aqueous compound, I said that you don't have to think. Okay, you just have to claim that equation. It's the same for dilute or aqueous. The equation is the same. So you write 4H minus to give what? 2H2O plus O plus what? 4 electrons. So this equation is just the same for aqueous and what? And dilute. You don't have to think. So cathode equation here. Okay, the cathode equation. The cathode is negative, so it attracts the what? The positive. Okay, for the positive we have what? We've got magnesium and what? And hydrogen. Okay, so for magnesium and hydrogen, which one is going to be attracted? So the least reactive will be what? Will be attracted. So here we have hydrogen and what? And magnesium. This one is magnesium. So which one is least reactive? The one below is the one next reactive. So hydrogen is what? It's going to be what? Attracted. So it's hydrogen. It's not hydrogen, it's hydrogen ion. Okay, hydrogen ion. So if it's plus, the electrons exist where? At the left hand side there, because it's losing electrons. Okay, it's now losing electrons to give what? The corresponding element. This is diatomic. We talked about this. So the first step, we balance the what? The hydrogens. We have 2, we have 1, so we put 2 here. 2, 2, it's now balanced. How many electrons? 2 times 1, we get 2. So that will be the equation for dilute or aqueous compounds. Okay, meaning that at the cathode we get hydrogen and at the anode we get what? Water and what? Oxygen. So that's what we observe. We observe at the cathode. What do we observe at the cathode? We observe bubbles of what? Of hydrogen. We observe bubbles of hydrogen. Okay. Okay, now we are doing electrolysis for concentrated compounds. Okay, for concentrated compounds. Okay, so electrolysis for concentrated what? Calcium chloride. Okay, so the first step, is to write the ions present. Ions present. What we have calcium 2+. We've got Cl- from chlorine. And what do we have again? For concentrated, I've said that there's also water involved, okay? So the ions from water is H+ and OH-. These are what? So these are the ions present. So going ahead, going to the anode equations. Anode equation is positive. So this one now is not dilute or aqueous. So there's no fixed equation. For this one, the anode is positive. So it attracts the what? The negative. Okay. The anode is positive. So you attract the negative. So the negative is what? Is this one and this one. Okay. It's this one and that one. Okay. So which one is going to be what? Which one is going to be is going to be attracted? So for concentrated, only for concentrated at the anode okay, or for negatively charged ions or anions, okay. So only for concentrated at the anode when attracting the negative ions, the most reactive will be the what? Will be the one which will be discharged. Okay, it's the one with the what? It's the one which is going to be discharged. This only happens for concentrated at the anode. Okay, so let's we have got chlorine and OH-. We have chlorine OH- here marked here. Okay, so which one is going to be attracted? In this case, I said that they are only for concentrated at the anode when attracting negative ions. The most reactive is what? Is chlorine. Okay, this only happens for concentrated, only for concentrated at the anode. Okay, at the anode when what? When attracting what? The negative ions. So we've got chlorine, the all processes are the same. Chlorine here. To get what? Okay, if it's negative, if the ions are negative, we form the electrons there because it's gaining, okay? It's gaining an electron. So we put the electrons where? At the right-hand side. So we put first we put the corresponding what? Element. Chlorine is diatomic. It's in that 7 formation which I showed you at the periodic table. So chlorine, CO2 plus what? We don't know how many electrons. First we balance. We have 2 chlorines. Put 2 here. How many electrons will go to the ions? 2 times 1 will get 2 here. Okay, get 2 here. So this will be the what? This will be the anode. Going to the cathode. The cathode is the what? Is the negative electrode. So it attracts the what? It attracts the positive. So here at the positive we have what? We've got calcium and what? And hydrogen. So looking at the reactivity series, now here the least reactive will be attracted. Okay, that only happens at the anode for concentrated. Okay, so we know at the anode, no, we are now back to what we're saying. We've got calcium and hydrogen. Okay, calcium and hydrogen. Here hydrogen is going to be what? Is the least reactive, is the one which is below, so it's going to be attracted first. So say hydrogen is losing. Okay, I'm now just explaining why we are putting electrons there. So if it's positive, electrons go away at the left hand side. So you say plus, because it's plus, which means we are losing. So it loses right there. Then it forms the what? The corresponding element to that, to the hydrogen ion. So the first step, what do? We balance. We have got 2 hydrogens, we have got 1, so we put 2. How many electrons? 2 times 1, we get 2 here. So these are the what? The equations. So if they ask you what happens, okay, so if I'm to draw the diagram for what will be happening here. Okay, we've got calcium chloride here, the one which is going to be what? The one which is going to be decomposed, or the electrolyte. Okay, the compound to be decomposed in electrolysis is called what? The electrolyte. I said that earlier. So this is the what? The anode, which is the positive. This is the cathode, which is the negative. So here, if they ask you what is observed here, anode, what is observed here at the anode? Okay, what is observed here? You don't have to guess. You write the equation and see what is happening here. So at the cathode, okay, this is the cathode, okay, this is going for the cathode. We have seen that hydrogen is going to be formed. So hydrogen is a gas. So we observe what? Bubbles of what? Of hydrogen. Observe bubbles of hydrogen. Okay. So at the anode, what do we get? We see the color for chlorine. Okay. Chlorine is a greenish gas. Okay. It's a greenish gas. So we see a greenish color here. Okay. Being formed around the what? The anode electrode. So that's what you'll be doing. If they ask you something about the electrodes, what do you observe here? What is formed? You write the equation. See, you don't have to guess. Okay. So that's the electrolysis of what? For concentrated compounds. You have to know the difference from concentrated and aqueous and molten. So here, just to sum up here on the electrolysis of our molten, aqueous, concentrated compounds. Okay. So when we do electrolysis, we mentioned earlier that electricity is passed through the electrolyte. Okay, that's the compound to be what? To be decomposed. Electricity is passed here from the positive to the electrode into the electrolyte and travels to the what? To another electrode and back to where? To the battery or to the power source. Okay, so here we have got electrode here. This electrode. These electrodes, they should be what? They should be inert. Okay, they should be inert. What does inert mean? It means that these electrodes should not react, should be not reactive. Okay, they should not react. They are non-reactive. They should not react. These electrodes, they are only serving the purpose of transferring electricity from this side to that side. Okay, from this side to that side. It's only for conducting electricity. It's not for react. So they should not react. So if they react here, it doesn't make sense. Okay, it doesn't make sense. It will affect the electrolyte, and there will be no conductivity of electricity from that point to that point. So the electrodes should be inert. So you're going to see that very often they will say that the characteristics of the electrodes, okay, they should not react with anything. Okay, then here, as electricity goes on, you're going to see that the color of the electrolyte will fade. Okay, it will fade. The color of the electrolyte, what? It will fade. As electrolysis goes on, the color of the electrolyte will fade. Let's say our electrolyte is let's say it's copper sulfate. Let's say copper sulfate, let's say the electrolyte is let's say yellow, okay, or let's say it's blue. If the electrolyte is blue, as the electrolysis process happens, you're going to see that the blue color of that electrolyte it begins to fade. It begins to fade. Okay, so that's a small sum up for what we've done now. So now let's go to purification of copper and electroplating. So now we are doing purification of copper, of purification of what? Of metals. So what I said when we were doing electrolysis of aqueous solutions or molten or concentrated, I said that these electrodes were inert, meaning what? Meaning they shouldn't react. They were non-reactive. Okay. So, but now when we are doing purification of metals, these electrodes, they will be now what? They should be reactive. Okay. So if you hear anything like when they say purification of electrolysis of copper sulfate, okay, using what? Using copper electrodes. That will be purification of copper. Okay. Electrolysis of copper sulfate using what? Copper electrodes. That will be purification of what? Of copper. If they say electrolysis of zinc sulfate using zinc electrodes, that will be for what? For zinc. Purification of zinc. Okay. If you notice something here, we have copper here and we have copper here. Okay. If they say electrolysis of a let's say an element X, okay, if they say electrolysis of X sulfate using X electrodes. That would be purification of copper. That's what they were meaning. Okay, electrolysis of dash sulfate using dash electrodes. That would be purification of what? Of that dash. Okay, if they say electrolysis, okay, if they say electrolysis of iron sulfate using ion electrodes, that would be purification of what? Of iron. Okay, so here what happens here is that this is the what? This is the cathode. Okay, this is the what? This is the anode. Sorry. This is the anode. The anode is the positive. Okay, this is the cathode. Sorry for that. So here, this is anode, this is the cathode. So what happens here when purification of copper? Okay, what happens here? So if we do electrolysis of a copper, of a dash sulfate, okay, of a metal sulfate using that metal electrodes, this is what happens. This electrode is copper, this is copper. Okay, so the anode dissolves. Okay, the anode dissolves here. It dissolves, and the copper, this copper, let's say in simple terms, let's say it dissolves, okay, and floats towards the what? The cathode, and it coats the cathode. Okay, it coats the cathode. So this one is the copper which dissolved, and it is the copper from this electrode which dissolves and what? And coated the what? The cathode. So the anode dissolves and what? Coats the what? The cathode. So what we see with time is that the mass or the size of this electrode, it will decrease because it will have been dissolved. Okay, and the mass or size of this one, it will increase. So that's what happens. So if you are to write the anode, equation for this electrolysis, this one is simple. The anode for copper, okay, copper, the anode is here. Okay? The copper is dissolving, so it dissolves copper 2 plus what? Plus 2 electrons. Okay, then for the cathode, you just reverse this one. You start with this one and add with this one. Why? Because the copper is now what? It's receiving. Okay, it's receiving this one. Suppose this one, it was this one. Okay, and it dissolved, like in simple terms, they say it's dissolved, okay, to this. So this thing is the one which is now floating to coat there. So it's going to come there plus we just reverse, okay, to copper like this. Okay, the anode, this one dissolved like this, and for the cathode, just reverse for all them, for all the purification of what? Of them. So that's what happens. So most of the time they'll ask you like what electrolyte do you use? Okay, I say that electrolyte is the compound which will be here to be decomposed. Okay, they will say what electrolyte do you use? Okay, if they are zinc electrodes, what electrolyte do you use? You just use what? Zinc what? Zinc sulfate. If they say what electrolyte do you use? If they put, let's say, copper here, yeah, if they say, let's say, what electrolyte do you use? If they use X electrodes, you use what? Use X sulfate. So that's those are the questions they ask sometimes, like what electrodes do you use? Okay, if the electrolyte is what? Is X, so you just use X electrodes. So it's purification of what? Of copper. Of copper sulfate using what? Copper electrodes. It's not always copper, they can change the metal here. So the content is the same. For the anode, I say that this one dissolves and coat what? The cathode. So for the anode, it dissolves like this. For the cathode, you just reverse the equation like this. Okay. So now let's go to electroplating using what? This same concept. Well, this same concept is the one which happens for electroplating. We are now doing electroplating, which is the process of depositing a layer of metal on another substance. Okay. So here the same concept which we did on purification of copper, that's the same thing that's going to happen here. Let's say we have a spoon. We want to coat this spoon with what? With copper. Okay, with copper. What do? We have seen that the anode dissolves and coats the what? The cathode. Okay. So at the anode, this is the anode, okay? The anode is the positive one. The anode dissolves. Okay, we've got the anode here. So this anode will be the what? The copper. So when the anode dissolves, it comes here and coat where? It dissolves. Then the copper, this copper, it comes here and coat this cathode. And what's at the cathode is the spoon that we want to what? To electroplate. So this copper dissolves and comes where? And coats the what? This spoon. So this spoon we coated with this dissolved copper. So that's what happens. And the electrolyte here is the same. It will be what? It will be copper what? Sulfate. Okay. Copper electrode using what? Copper sulfate electrolyte. So that will be the what? The electrolyte. So this is what happens. Okay. This is what happens at what? Electroplating. So going ahead with the equations. Anode. Okay. At the anode here, the copper is what? Is losing. Losing, okay? Then at the cathode, you just reverse, okay? Because it's now receiving the what? These things which have dissolved at the anode, coating the what? The cathode. So you just reverse the equation like this. So this is the electrolysis of what? This is the electroplating, okay? So the substance to be coated is placed away. It's placed at the cathode. And the metal to which we want to use to electroplate or to coat is placed where? At the anode. Then the substance to be electroplated is placed at the what? At the cathode. Why? Because that's where this dissolved metal is going to come there. So that's it for electroplating. So thanks for watching. Make sure you subscribe and hit that notification bell because I'll be releasing more related content